I'm going to introduce Mitch Wagener. He teaches ecology, the science of climate change, and related courses at Western Connecticut State University in Danbury. In 2019, he received the Aquarian Environmental Champion Award, Individual Communication category, and an official citation from the Connecticut General Assembly for his efforts in climate change education and community service. So we're all excited and enthused. So I'm going to turn it over to Mitch.
I always like to start with this picture for a couple of reasons. One is I remember 1968, as some of you, the rest of you do as well, when the Apollo space flight took a couple of turns around the moon and then came back, and in so doing took pictures of Earth. These were the first photographs we had that had one side of the Earth entirely in one frame. For those of you who were in college in the 70s, you might have had a poster of this or a flag on your dorm room wall. They were very popular. Well, this isn't that picture. This is a modern picture that is made up of a composite of satellite images. But I like to show it for a couple of reasons. One is it shows us something about how active the atmosphere is with the clouds arranged in curlicues. That's because of the Coriolis effect and the spin of the Earth. But it also tells us something that's very important, is that how beautiful the Earth is. If you were out in a spaceship looking on Earth, you would see this beautiful blue dot with green and white against a background of the blackest black that you can possibly imagine. And it's just beautiful. And we need to keep in mind that this is all we got. You know, there's no planet B, as they say. I like to make the distinction between climate and weather. People get this confused sometimes. Climate is the statistics of temperature, humidity, atmospheric pressure, wind, rainfall, and so on, over a long period of time, over a large area. In fact, statistically speaking, you need about at least 30 years worth of data to actually describe the climate or a change in the climate. Weather, on the other hand, is basically what's happening in your backyard. So when I was looking out my window today, I saw rain and snow, and that was weather. That's the difference. It's a difference of scale, something in fine grain or something in coarse grain. Another way to say it is that climate's what you expect, but weather's what you get. Now, you might have heard our climate's warming up. And we see this in the global mean temperatures. These give you, these kind of bell curves here, give you an idea of the global mean temperature of these years and also how broad it was or how narrow. It's just another way of portraying this data. And notice that, first of all, the warmest year on record up till now was 2016. 2019 last year, which is the last year we have full data for, was second, a close second. Notice too that of the 10 warmest years in recorded history is defined by after 1880, because that was about the time we could actually start making these kind of estimates. All of them have been, all the warmest years in recorded history have been since 2005. Now, what I'm hearing is that 2020 is likely to be even warmer than 2016. And one of the things that's a little bit disturbing, which is a subtlety which you might not have picked up on, is that there is year-to-year variation of temperature. This year is different than last year, which is different than the year before, and so on. And there's a number of different reasons why the temperatures are different in these different years, year-to-year variation. There's a trend, the trend of increasing heat trapped in the atmosphere by fossil fuels. That's the trend, but there's variation around that trend. And that's what you see with these squiggly lines. One of the things that drives the year-to-year variation is this thing called El Nino, or more precisely, El Nino Southern Oscillation. It's an oscillation of two states in the South Pacific Ocean. Whether you have a high pressure system in one spot and a low pressure system on the other, whether they're reversed, And they pretty much screw around with the weather all over the world, including here. Okay. El Nino is one state. La Nina is the other state. And it's anything that's a positive number on this calculation they make is, called an El Nino, and anything that's a negative is a La Nina. Within the trend, these high numbers are all El Ninos. I'm pointing at the screen, but you can't see what I'm pointing at. All the high numbers within the trend are El Nino, and the low numbers are La Nina. Well, 2020 is going to be the hottest yet, and it's a La Nina. Okay, that's ominous because it breaks our trend. It breaks what we thought we know about the effect of El Nino on year-to-year variation in temperature. We'll just have to wait and see exactly what that means. We don't know. Now, another way to look at the weather or the temperature on a given year is through a map like this, where each spot, each pixel in that map is the comparison of the average temperature for 2019 compared to a benchmark, which is the 1951 to 1980 average. Notice that the benchmark is the same, 1951 to 1980, a 30-year average, which is our comparison. It can be, depending on who's making these graphs, they'll use different benchmarks, but they always tell you what the benchmark is. Notice in 2019, anything that is reddish is warmer than the benchmark, and anything that is bluish is cooler than the benchmark. Yes, there are a few cool spots. Notice that the northern plains were cooler than average last year. Notice that there's a pale blue dot south of Greenland. That has been there persistently for the last decade, at least, and it's basically caused by melting ice from the ice sheet on Greenland. Notice that there are a few other odds and ends of blue here and there, but notice that there's not much of it. And that's the way it is year after year after year. You notice that some of the warmest places on Earth are near the poles, the Arctic Ocean, and to a lesser extent, Antarctica. We'll talk more about that. The Arctic basically is warming up at 2 to 3 times the speed of the rest of the world. It's well worth noting that there's any number of different indicators that tell us that we are in a warming world. If someone wanted to be skeptical about this, and there still are a few, although I encounter them more rarely than I once did, it's just not just air temperature at sea level, okay? It's how much mass there is in the glaciers and whether snow cover is melting and whether the tree line's shifting northward and the sea level's rising and all these things. You can read them. If a person was to make a great cosmic pronouncement about the state of the world based on one variable, anyone would be justified in saying, well, really? How do you know that for sure? The thing is, what we have is a whole bunch of these things that are all telling us the same thing. These are all independent lines of evidence, independent variables that are measured by different people using different gizmos in different parts of the world, and they're all telling us the same thing. All of them indicate it. The truth of it is, however, that you almost don't need all that evidence. The ice is enough. If the world was cooling down, then the mass of ice on average would be growing every year. It's just physics. If you warm up the environment, the ice cubes melt. If you cool it down, they may increase, in size. What we see is a very persistent trend toward decrease in the amount of ice on the Earth. There is no way that would be the case if the climate was warming up. The rest of the stuff is telling us basically the same thing, but the ice is the kicker. If you ever get in an argument with somebody, your crazy uncle at Thanksgiving next year or whenever, and who doesn't believe in climate change, just say, well, the ice is melting. It wouldn't do that if it wasn't warming up. Not that that'll convince them, but you can try it. there was a paper just this a few months ago that basically tried to put data to all those little arrows. And, and I won't go through all this, but you can see the carbon dioxide on the upper left, carbon dioxide concentration going up, methane going up, and so on. Every one of these trends is showing something like one of those little arrows in the previous graph. Scientists call this consilience, when we have evidence from independent, unrelated sources that converge to strong conclusions. That's a term that E.O. Wilson at Harvard has written a book about. And if you look at all the big scientific ideas, whether they be relativity or climate change or natural selection, the evidence for them all come from independent lines of evidence that are pointing in the same direction. Okay. Since I started framing climate change in terms of consilience, I don't get much argument from skeptics anymore.